integrate this. So how are we going to do it? Well, you know what we do. We almost always let u be what's inside a root, inside a log, inside a parentheses or sine, cosine, tangent, exponential function, whatever. The inside piece. That's almost always what we let u be. So u is going to be the x plus 4, not the root, just what's inside the root. X plus 4. Okay, so we do that. Then this becomes the integral of 6x square root of u dx. So we still have some other x stuff, excuse me, that we need to replace. So how do we do it? Well, take the derivative. Du dx, what's the root of that? It's just going to be 1. You okay with that? There's 1. Power comes down. Subtract 1 from the power. The x is gone. The 4 is just 0. Okay, multiply both sides by dx. Boom. So du is 1 times dx. In other words, du is just dx. So that dx right there, that's du. So now we have, bring it down here. Now we have the integral of 6x square root of u du. So we're able to replace the dx with du because they're the same we just showed. So now we just got that guy, right? Because we got to get rid of all the x stuff, make it into a fully u, make it all u integral, and then we can finish up the problem. How do we do it? What do we do with that x? This is where you can get lost. Well, here's the trick on this one, right here. If you look at this, if we grab this, let me just bring it down here for a minute. U is x plus 4. I can actually solve for x right there, right? Just subtract 4 from both sides. This goes away. So x is what? U minus 4. That means wherever you see x, you can replace it with u minus 4. So that means right here, this is u minus 4. So this integral becomes integral of 6 u minus 4 square root of u du. Right? That x becomes u minus 4. So now it's all u, as the saying goes. It's all u, so now we can do it. But still, right now it's two um, letters multiplied. We can never we're not ready to do the antiderivative quite yet. We can't have letters multiplied or added. Numbers are fine. We're fine with like a 6 multiplying, whatever. But we can't have two letter expressions multiplying or dividing. We can have letter expressions added and subtracted, but we cannot have letter expressions multiplied. We don't currently have a way of doing the antiderivative of two letter expressions multiplied or divided. We'll get it. It's called by parts. It's in Calc 2. It's pretty tough. We don't have it right now. So we can't have things multiplied. So we got to multiply them out. We got to distribute them. So what I'm going to do is I'm going to do a couple of steps to make this a little easier. I'm going to say, look, let me just bring this over here. Just rearrange it. 6 square root u minus 4 du. And that's fine, right? Because you can see, like I just changed the order of multiplication. If you have, just think about numbers, 2 times 3 times 4. That's the same thing as 2 times 4 times 3. It's 24, whichever way you do it. It doesn't matter. The order of multiply never matters. That's what we had going on here, right? We have 1, 2, 3 things multiplied. I just switched the order there. Why? It just makes it easier to distribute. And not only that, I'm going to say, look, square root of u, that is, as you know, u to the half power, right? Okay. So I'm going to take that 6u to the half power. I'm going to go boom, boom. I'm going to distribute. So we get the integral of, so what's going to happen? This is a 1 powers add 6u to the, I'll go 1.5 minus, and then this guy multiplies this guy, 24u to the 0.5 du. I distributed through those parentheses. Now, why is that so great? Now I just have two letter expressions subtracted. That's fine. We can do the antiderivative for that. We're ready to go. It's antiderivative time. So the integral and the du, those operators are going to do their operation. We're going to do the antiderivative. So let's add 1 to the power. So that'll become 2.5. And then this is 6 over 2.5. We'll divide by that, right? That's how we do the anti. And same thing here. Antiderivative in this guy minus. Therefore, add 1 to the power, u to the 1.5 over 1.5. There we go. I'm just going to leave those. You can try to simplify those numbers. It doesn't matter. Let's leave it 6 over 2.5. And now just write these as 2.5 here. Minus 4, 5. What is u? What has u been all along? U was x plus 4. Right there, u is x plus 4. So where we see u, replace it with x plus 4. See u, replace it with x plus 4. And there we go. There's the antiderivative. We did it. Is it the right answer? Yeah, you can see they have the same thing. They have a little bit different format. Ours is right. They'll take it this way. 24 times 2/3. Yeah. Yep, it's the same. X plus 4, 3/2. Yep. It's exactly the same. You type this in, it'll take it. And they have the plus a constant for us. So there it is. So it's a little tricky. So one more time. The name of the game, we always let u be the whatever's inside. So that's x plus 4. Then we do the derivative. Then we start replacing stuff. So this becomes square root of u. Dx becomes du. We proved it right here. So then we just get this extra x. That's the extra trick. How do you get rid of that x? Well, you go back to your original setup and you just solve for x. X is u minus 4. So replace that x with u minus 4. Then you just got to move this over, distribute like that, and then just do the antiderivative on each part. Because again, you can't have two letter expressions multiple. You might think, I know you're kind of new to integrals right now. You might think, oh yeah, just do this, just do the rule on that one, do the rule on that one. No, not multiplied. The antiderivative rules are only for letters added, subtracted, not letters multiplied. So we have to distribute to make them subtracted. And so there we go.